Hi everyone. Do you have any idea what is related rates? Related rates problems are problems that involve two or more quantities and their corresponding rates of change with respect to time. The relationship between these quantities is used to express the related rates in terms of the other quantities, known as the rate of change. Related rate problems are word problems where we reason about the rate of change of a quantity by using information we have about the rate of change of another quantity that's related to it. But why do we use related rates? Related rates come in handy when we have two related quantities and one of the rates of change is much harder to find than the other one. For example, look at the figure below. You can see that it is difficult to find the rate of change in radius of the balloon while it is being pumped up. For example, a spherical balloon is being filled with air at a constant rate of 2 cm cubed per second. In this figure, how fast is the radius increasing when the radius is 3 cm? Look at the figure above. As the balloon is being filled with air, both the radius and the volume are increasing with respect to time. The volume of a sphere of radius r centimeters is V is equal to 4 over 3. The volume of a sphere of radius r centimeters is V is equal to 4 over 3 pi r cubed centimeter cube. Since the balloon is being filled with air, both the volume and the radius are functions of time. Therefore, t seconds after beginning to fill the balloon with air, the volume of air in the balloon is V times t is equal to 4 over 3 pi bracket r times t bracket cube centimeter cube. Differentiating both sides of this equation with respect to time and applying the chain rule, we see that the rate of change in the volume is related to the rate of change in the radius by the equation V prime times t is equal to 4 pi bracket r times t bracket squared r prime times t. The balloon is being filled with air at a constant rate of 2 cm cubed per second. So V prime times t is equal to 2 cm cube per second. Therefore, 2 cm cube per second is equal to 4 pi bracket r times t bracket squared centimeter squared times r prime times t centimeter per seconds, which implies that r prime times t is equal to 1 over 2 pi bracket r times t bracket squared centimeter per second. When the radius r is equal to 3 cm, r prime times t is equal to 1 all over 18 pi centimeter per seconds. And that would be all. Thank you so much for listening.